Let me introduce you to my Warco drill press. But could it be improved? Hi there, welcome back to episode 5. So in this episode we'll work on the pulley. We need to get it skimmed, bored out and a keyway cut. Then we'll move on to the main block, so we need to get that trimmed down and then the surface skimmed flat so that we can mount our drive plate to it. Let's get going. So in the last video you might have seen that somebody had the great idea, just saying, of, or rather than reinstalling the motor at the back here and having the 3 pulleys, why don't we put the motor here, have it inverted, and then have it on some bracketry, and then basically just drive it off a single belt, and then maybe just have a couple of speeds here. So the motor would be with the shaft pointing down and the main body here. A couple of advantages of doing that are we can crop the back of this, probably the last, probably 180, 190 mil, so that's whatever that is in inches, 7 inches, off the back of it. And the reason for that is, well, yes, it would make it look a lot more compact, have it quite neat and tidy up here, because we're not after all the multiple speeds, we've got the variable speed already there. The other nice thing is, because it's quite wide front to back, I ended up having to hang it slightly off the front of the bench, and then I only bolted it down at the back. And that was okay, because I had some really chunky bits of wood, and the plan was I'd just add a piece onto the front of the bench, onto the front of the tabletop, and then I'd bolt it down to there. So that was the plan, and then fast forward to about 4 years later, and yeah, it's exactly the same. So yeah, it was kind of good enough really, but it would be nice to move the drill press back to the wall a bit and make a little bit of a tidier job of it. So that's the plan. Since we're going to mount the motor up here, we don't need this anymore. We also don't need the adjustment down here, so we don't need this cam arrangement. So although I did leave it in place because it wasn't really in the way, I'm going to take it out. So yes, if you're counting, that's yet another piece that's not going to go back into the final drill press. There we go. It's actually quite nicely made. Okay, back into the bits pile. Now the other thing to say is, because the motor's going to be here, it's going to be mounted off a plate that will sit on here, and I'll pick up off these. They look like M5 tapped holes. So these were the holes that held down that yellow belt guard, so I'll reuse those. The only thing is this surface just being cast, which I'm sure you can imagine is not very flat. Yeah, it's got lumps and bumps all over it. So I could set it up in the milling machine or the CNC machine. It's quite tall, but I think I might be able to recess it down at the end of the bed where there's a bit of a pocket. But it would be a lot of setting up, so essentially what I'd have to do is probably make something to fit onto this taper that turned it into a parallel shaft, and then screw that on, and use this as my guide to dial it in to get this square to that, so the machine was square to that, and then machine this surface at 90 degrees to this surface, because the motor's going to be on here, and then the belts would have to be, make sure those belts were and pulleys were in line with each other, otherwise the belt's going to wear out pretty quick. That's one option. The other option is next to each bolt just have some grub screws that just create a kind of levelling surface. We level it and dial it in until this surface is sort of 90 degrees to this. So still thinking about the best option on that. Quite fancy machining it, but it's a lot of work, so I might go with the grub screws. We'll see. So the motor will be roughly there relative to the head, and then here's the original drive pulley. It's got a tapered bore in there, it fits on that tapered shaft. Right. Yes. Okay, just hold that on loosely. And then the other pulley will be on here, and then there'll be a an arrangement to hold that, and we can adjust the tension, and then we'll crop this off. Right, so we need to think about how we're going to drive this and what's the best pulleys to use. Now, the original belt that comes with the drill press is an O series, so that's the shape of the belt, and it refers to this section here, these dimensions here, and obviously then the pulleys are O series pulleys. What I really wanted to do was to, well, there are a couple of options really. Obviously that's tapered on there, so that limited my options there, but what I wanted to do here was get one of the taper bore type pulleys. So you've got a taper that screws onto, or slides onto the shaft here, and then the pulley sits on top, and you tighten the two together and it just tightens it all up. Quite a neat way to do it. But all the pulleys I could find were either A profile or A SPA, Z, SPZ, some other profiles. There was nothing that was an O profile that would take this belt on a pulley that was a taper lock type pulley. In fact, I couldn't find any pulleys that were this section here. Seemed to be quite popular belt on like washing machines and things like that, so maybe it's a kind of low grade sort of consumable type belt like that. So options were, well, I could machine my own pulley and then grind up a tool to this form and then machine the shapes in there on the lathe. That was one option. But what I think I'm going to go with is I'll take the pulley off the old motor that was at the driven end over here, and then have a look at that. Now that's a 19mm shaft and this is a 24. That was on a grub screw, and this one's, as you can see, is on a Keyway. So it's going to need boring out, so we'll have a look at that and see how many pulley ends we end up losing when we bore that out, because I think we'll probably lose some of the grooves. But let's go and have a look at that option, because that's probably my cheapest and easiest option. Let's go and see that now. Okay, so here's the pulley obviously off the old motor. I'm just about to relieve that. I didn't have any of these pullers, as I mentioned in the last video, so I went down to Screwfix, like on a trade hardware store in the UK. So I went down there this morning, and they were out of stock with the name brand one. But for the same price, they did have a set of 3 of these. So for the price of the 100mm one, or the 4-inch one, which is what I went for, they had all 3 about the same price. Now this is a very budget brand made in China. Well, actually, as they all are. So I'm not expecting too much in terms of quality, but I needed it. I think this will be relatively light duty, so hopefully it'll do the job. And then I've got a couple of others, the other sizes as well, if I need other jobs in the future. And when they made this pulley, there was a pilot bore in there, I think about 4.5mm. So I've got it's a cap head screw in there, and that's pushing down onto the shaft itself, and that's what we're bearing on. And then the outer part's obviously pulling up on here. And I've just taken the tension on it, so see if we can go a little bit further, and then I'll probably have to swap that out for a longer one. So we'll just literally just tighten this up. It's not too tight actually. Right, bottomed out there, let's get a longer bolt in. I'll say I feel alright so far. I guess if you put too much load on, these forged ends might be the first to go. And I was a bit surprised that the thread they use is just trapezoidal thread, as you can see, and it's not an Acme thread. It's not really the strongest thread in the world. I dare say if it did go, I could maybe bush that out and put a nice one in. Right, let's get a longer bolt in there. Okay, see if that's a bit longer. Oh yeah. Just tighten it up. Okay, it does look like we have got a keyway in this one. And then there's the locking set screw. That's good. Okay, so I've just had a quick measure up of the pulley, and we measure that one there, because remember we're going to need to bore this out to 24mm. So if we look at that, it's around 29, but don't forget we're going to have to put the keyway in as well, so I think we'll end up losing those two there, and we'll just have these two here, and those measure up at 60 and 46. I'll just measure to the bottom there just to keep the comparison the same. So it's the base of the pulley there, that's 40 on that one, sorry, 46 on there and 60 on there. So I think I'll probably end up running it this way round. Obviously we'll lose those two, and then on the other end that joins to 70 and 80, and then they get larger as they go down on the spindle end. And that'll be about right actually, because I'm looking for just under 1:1 for the general use, so we'll go 60 to 70, so there's a slight gearing up. And if we're really wanting lots and lots of torque, we can run 46 to 80. Obviously we'll lose a lot of speed, but if we've got a really big drill or we're struggling for some large boring operation, then we can use that one there. I don't think we'll ever want to use the larger ones, but if we do, there's probably enough shaft on here that I could, if I really needed to, undo this, slide it down and have it running on one of the larger ones. But I imagine I'll just stay with those two and then just use the inverter to vary the speed. I think that will cover all my needs, especially if we've almost doubled the power of the motor. Okay, so we're over at the lathe. I just reversed the jaws. I'll put the opposite jaws in to hold it on the outside. I've just pushed it tight up against the back here, so it's roughly square. What I'm going to do is, because that's not completely square and then it's not easy to indicate, I'm going to take off these two with the parting tool, and that will expose the 19mm bore that's inside. Then I can pick up off that and centre it. I might be able to knock it around in here. If not, I'll put the four jaw on, maybe put some dowels in here, some metal dowels, and hold it that way. We'll see. But first of all, let's part this off so we can expose the bore in the centre, so we can indicate off that. Okay, we're through. Okay, we'll just clean that face off now. Okay, I think we'll leave it there. So we've left a little bit on, so we'll reposition this. I'll have a look, see if I need to do it in the four jaw, but now I can dial it in based on that bore in there, and then once it's square in the lathe, then I can face that off correctly so it's completely flat. Okay, let's set this up so I can centre it. Okay, so I've got it set up in the four jaw now, and I've just dialed it in. It's pretty concentric. Obviously it will jump a bit on the keyway. We go across the keyway there, and then pretty much back to zero. Probably within about 0.01, which I think's okay. And then if we just traverse it down the bore, let's try again. 0.01, 0.02, across the keyway. 0.01, 0.02. I've been playing around for a little while and I think I'm pretty happy with that, so we'll leave it at that and let's bore it out. Actually, the first thing we'll do now we've got that centered up is we'll just skim across here so we've got a flat surface, just give us, in case we need it as a reference. Okay, one of the things to watch out for when you are using the jaws backwards is they stick out a long way. So I've got the boring bar slightly past the end of the cut, just to check exactly how far I can go, and you can see that that step there, it just clears on all four. So I know that that's about the limit of travel. Now if I had one, I could put a stop on here, physical stop, just to make sure, but I'll just check the DRO and make sure I don't go too far. So it's always worth checking, sort of doing a dry positional move just to see where you're going to get up to, and just check you've got clearance. Right, let's finish this bore. Okay, so we've got 22.5 on there. We'll just make sure we're on track. We're aiming for 24. So this is a 2-point micrometer for measuring crossed diameters. Quite like this, and it's got a little thimble ratchet built in as well. So let's see where we're at. Somewhere there. Ratchet 22.44. So we'll adjust the readout. Right, next cut. For 24 or 24.01. This is the final dimension now. So just got it. Okay. So we're 24.01. That's perfect. Okay, let's take it out. Okay, let's see how it fits. Obviously I haven't done the keyway yet. It looks like it just about wants to go on. Yeah, it's just slightly getting tight. So it goes on. It's not hitting the keyway yet, but it's... looks like it almost wants to go. So what I think I'll do, we'll do the keyway next, so we'll get that in line with the set screw there. So we'll put a keyway in there, come back and then just polish this bore out just to take any slight roughness off, and I think that'll probably just gently go on there. Yeah, I don't want to open it out anymore, I think it'll be too loose. Right, next, keyway. So we've got the bore out to the correct diameter now. Now we need to put the 8mm keyway in. So I'm going to cheat slightly and just use an end mill. That will save me having to get square corners. So it'll be slightly oversized, slightly rounded corners, but I think it'll do the job. So the first thing is we just need to check that the vise squared up. So I think I've done that. Let's just show you that. That's close enough. Right, let's get the pulley set up, center on that bore, and then we can start cutting the keyway. Okay, and there we go. Keyway finished. Okay, let's see how well it fits. I think it's very close. Yeah, it wants to go. It's very... I don't think it's catching on the key. It's just on the diameter. Yeah, I think we'll just lap that in rather than force it on. Okay, so what we're going to do is just get that in the vise. And then I've just got a bit of emery cloth just taped onto, what that is, oh yeah, just a socket, and then just held on with a nut and bolt. And we'll run that in reverse like that and just flap round and kind of lap some of that. We'll just keep repeating that until we get it a nice tight fit. I might end up marking it with a Sharpie just to see where the high spots are, but let's see how we go. It's important not to apply too much pressure in any given direction. If you can try and float it in the middle and let the inertia do the rest. Let's give that a try. So I've lapped this and tried it repeatedly, probably about 10 times, until I think I finally crept up on the fit I wanted. And while I was there, I just squared off the edge of that keyway just to make it look a bit nicer as well. It's actually very smooth in there, and as you can see, I just want a reasonable push fit, because I want to be able to adjust this to align the pulleys when it's all up on the drill press. I don't want to have to kind of get crowbar in there or anything to move it. So we just got this kind of fit now. I can just about push it, there we are. So I can get that into exactly where I want it in terms of belt alignment by reaching in, and then I can put the set screw in there and lock that off, and that's a nice snug fit. And we can lock it in place with this M6 grub screw, so it locks down onto the key there. Should be just under flush. That's it. And then this shaft here is tapped M8, so let's see if this will work. This is just to stop the pulley falling off if it all comes loose. Yeah, I'll tighten it up later, but it looks like that will work because it's larger than the shaft. Okay, yeah, looks good. Okay, pleased with that. If you remember, there were a couple of options for mounting the motor. So basically I wanted to create a very flat plane because the castings left a fairly uneven surface, and I want to bolt a plate onto the top of that and then grow some motor mounts off that. So because it was quite bumpy and uneven from the casting, two options. One was to put some grub screws in that plate so it would kind of I could level it out that way. The other option was to get it set up on the CNC machine, assuming it will fit, and line it all up and then machine the head flat. And that's the option I've decided to do, so let's get started. Right, so we've got the block clamped up against this drawer here. It's pretty solid now. I've just marked that up. I'm going to chop this bit off here. Whew, there she goes. Right, let's get this on CNC machine. We can get it all jigged up so that it's true to the axis of the spindle. Then we can machine that edge so it's a little bit tidier and straight. And then we'll skim this surface so it's flat relative to this spindle axis. a little bit lighter now. But not much. Okay, so I've got the block on the CNC table. First problem is I can't get the gantry just past the top of the spindle. It fouls it by about 2mm. Now, I could lower the spindle by turning the handle, but it's currently resting on the other end of the quill, so basically I'll just lift the body up and that wouldn't work. So I think I'm going to have to drill a hole in the table just to relieve it. So the bottom of the quill, there's a round section like that, just so it pockets it inside and lowers this down. Good news though, it looks like, look at the back over there, I've got clearance to actually get the milling cutter onto the top of it, so it is going to be doable. I just need to get it all into position. Right, I'll bring you back in a bit. Let's talk you through the setup so far. So it's not complete, but we've got part way through. So we've got some all thread at the back here that holds the casting. So it's held onto this side here with these two M10 nuts, and the same that side. And then the thread protrudes out and it's held in the vise in some protective aluminium plates just to stop it marking the vise jaws. So we've got that there. And then here we got a ground bar that's held on the underside of this pulley. So basically this represents the plane of the pulley, so it's flat like that. At the moment we're just checking along this axis. I've got the DTI dialed in there and we'll sweep that along in a moment. I've got it pretty close. At the front here, you can just about see in the front of the shop, just a scrap I found that managed to match up here. So we've got that bolted in at the front and then clamped down there. So we've got it held at the front and hold at the rear. And I've just been shimming it out down the bottom here and at that side to try and get it level, at least in this plane. So we'll try and get it level in this plane first, and then I'll have to check across that way and then try and square it up. So there's quite a lot to get done, but this is how far we've got. I think that's pretty close enough. Okay, now we've got to check 90 degrees to that and see where we're at. I'll just spin this round. Now we're going to check in this axis. Right, now we've got it set to do the other plane. We just rotated this round. Yeah, I think we'll go with that. Okay, and then we'll just recheck in the other direction, make sure nothing's moved. Right, so we need to make sure everything's tightened up. We'll take the pulley off and then we can start skimming the head. Okay, I've got everything locked in place. I've protected the bearing. We've got some covers in here because the rack is still exposed and I don't want this cast iron dust going into the mechanism in there, so that's covered. And then I've checked all the clearances. I've just done a kind of free pass round. I've got the bit sticking a fair way out of the collet. It's the only way I can make sure I can get to this without it clashing the top here. But we're only going to take some very light cuts, so I think it'll be okay, so let's get going. Okay, so I've just been taking off the high spots. You can see it's starting, I think this corner was the highest, and there's a little bit at the rear there. So this side's maybe 1mm lower, so we've got a fair bit to come off. And just in case it's, well, just to check that it's not been moving during the machining, I zeroed this off on top of the pulley, so whenever this is 0, it's in plane. So if we just have a look, we're just making sure Okay, that's pretty good. So it hasn't moved. It saves me having to put the pulley on each time and dialing it back in. So I know this is not super accurate to the degree that we want, but it's yeah. Okay, so that looks okay, and then we're just checking forehand as well. Okay, pretty close. This, as I say, is just to check to make sure nothing's moved massively. Once we get to the final cut, I'll probably just dial it back in again and just check. Definitely nothing's moved, but this is just a very quick handy check. Right, let's get going again. Okay, let's check the levels very roughly. Okay. Oh, pretty close. Okay, and then lengthways. If you can see that, it's on about 0. Lengthways this way. Looks pretty good. Okay. Right, that's pretty close. Okay, it turned out okay. So now I know that's going to work. I'll order up the materials to make the motor mounting system. So there'll be a plate that sits on here. It'll screw onto these M5 holes. I might pick up off that one as well, drill and tap that to whatever that is, maybe M12. It'll extend out the side, so it'll also be picked up on the bits of the column that come up on the side as well, so it'll be pretty secure. But now I know that's going to work, I can order those materials, and hopefully in the current situation those will come in due course, and then we can get on with the next part, which is mounting the motor. Okay, well that's it for this video. Thanks for watching, stay safe, hope things are okay with you, and see you next time.